Okay, this is our 2.4 algebraic reasoning. We're actually going to dive more into proof-based problems here. Okay? I'm going to start way down here with definitions. Okay, and then we'll go back up to the top. I'm going to write these equations, or write these definitions. You can write them in your own words, however you want to remember these. But an equation, we've worked with the equations forever. Okay, you guys have been working with that for a long time. An equation, I'm just going to write something like this, where we have something on the left side of an equal sign and something on the right. That's an equation. Okay, but the big thing with an equation is right here. It has to have an equal sign, otherwise it wouldn't be an equation. Okay, that's an equation. When we solve for an equation, what we do is we manipulate both sides of the equation to leave one variable alone. Okay, like when we solve for x, we want x by itself on one side of the equation. When we get that, we solve for x. A formula is facts or definitions, anything in math form. And that's really a broad definition. A formula is something to help you find the solution. Okay? And I want to talk about what's below here. Okay? These algebraic properties of equality. All right? And these are what you're going to be using through this lesson's homework, so please pay attention. You have the addition property of equality. Okay, so if you have A equals B, then you can add something to both sides. Whenever you add something to both sides of the equal sign, that's the addition property of equality. You add to both sides of the equation. The subtraction property of equality, well, you're going to subtract on both sides of the equation. And whenever you subtract something on both sides of the equation. Multiplication property of equality, I bet you can guess what that means. Yep, we're going to multiply by both sides, or on both sides of the equation. This says C cannot be 0 because if we said we multiplied by 0 on both sides, we'd get rid of everything. We don't want that. Division property of equality, yep, we're dividing on both sides. Okay, and then the substitution property. This one can get a little tricky. A substitution property. If A equals B, then A can be substituted for B, or B for A in any equation. So if I had an equation, let's say I have this for sure. A equals B. Okay, and I said B plus D equals G. Okay, whatever those may be. I have that equation on the right. I can now substitute, because I have A equals B, I can now substitute this B with A and say A plus D equals G. Okay, that's the same exact equation because B equals A. The substitution property. Think if I had a substitute teacher come in for me, okay, they just replace me. All right, so I'm B, my substitute is A. It's the same equation, same type of day, nothing changes. Okay, now, let's go work on these up top here. So what we're going to do is we're going to solve, well actually they kind of solve it for us. All we need to do is justify the steps. Oops. Sorry, I forgot one. Down here. We have the distributive property. Hey, you guys know how to distribute things? When we have an A outside the parentheses, we multiply to both sides, or what's in the parentheses, we multiply to both, or everything in the parentheses. So we get A times B plus A times C. You guys know how to distribute. These last three down here, if we have the reflexive property. Reflexive, what do you think of when you hear the word reflexive? I hope you think of reflect. Okay, because reflect is what's happening here. We have A equals A. Both things, or the same thing on both sides of the equal sign. We have AB equals AB, or the measure of angle A equals the measure of angle A. And when you see your own reflection, you see yourself. That's the reflexive property. Both sides of the equal sign has the same thing. The symmetric property. The symmetric property. If A equals B, then B equals A. Okay, so it kind of flips on both sides of the equal sign. A and B flip. Right, and then the transitive property. I want you to pay attention. This is like the law of syllogism, okay, the chain rule. If A equals B and B equals C, well then A equals C. Okay, see, it's a chain rule. Don't get this mixed up with substitution, okay? Because we're not substituting. We have more than just flipping out one thing for another. We have two now. We have A equals B, okay? B equals C, so A equals C. Kind of that two parts. Two things equal the same thing, right? A equals B, C equals B, therefore A equals C. That is transitive property. Now let's go up here. Let's start solving for these. Okay, so we're just writing the justifications. So we wrote the given equation, that's good. What happened in this step? What happened? Well, what happened from this step to this step? It looks like all they did was distribute this 2x, or this 2 to both sides. So what are we going to write? We're going to write distributive property. Yeah. And then what they do from that step to this step? Well, the only difference I see is right here. They went from 6 minus 5 to 1. What's that called? It's not the subtraction property of equality because we didn't do it on both sides of the equation. All it is combining like terms. Okay, and if you wanted to say CLT, combine like terms, that's fine with me too. What do we do from that step to this step? Looks like we're subtracting 2x from both sides. Okay, what's that called? That's a subtraction. Property of equality. A subtraction property of equality. From that step here, what do we do? All we did was simplify, right? All they did was simplify. Okay, nothing really changed. We just took the 2x away from both. What do they do from that step to this step? Looks like we're subtracting 4 from both sides. subtraction property of equality. Okay, this next step, what they do, all I did was simplify. Almost there. What are they doing there? I'll scroll down. I know everything's going to get kind of mixed up here. So I'm going to erase all this. Okay, we are right here. What happened? We're dividing on both sides, right? So division property of equality. And then what is it? The last step? Almost. Okay. So from here to here, what they do, they simplify, right? From here to here, doesn't look like much. In fact, nothing really changed. It's one of those three that I talked about, either reflexive, symmetric, or transitive. And what happened? We flipped the side of the equal sign, right? So it is a symmetric property. Hey, no, it's the same thing, just with multiply and divide. Up here, the symbols, the diamond and circle represent, it represents addition and multiplication. Not necessarily in that order. We're going to determine which symbol represents which operation, and then justify your answer. Okay, so all we're doing, we're not doing what we did above. What we're doing is just looking at one of these apiece. So this is 1. It's going to be 2, right? So we're only looking at those. 5 times 6 equals 6 times 5. Is that true? 30 equals 30. Yep. What about 5 plus 6? Does that equal 6 plus 5? Yeah. So it can be addition and multiplication. Okay, we can't really decide there. Okay. How about this one down here? Circle. Same thing, right? Don't really know. It's 5 times 6 equals 6 times 5, and 5 plus 6 equals 6 plus 5. How about this one down here? Let's try and multiply first. Let's try and multiply. Okay. Inside the parentheses, we have 5 times 6 is 30. 4 times 30 is 120. So we'll have 120. Does that equal the same thing over here? We have 4 times 5, which is 20. 20 times 6 is 120. Okay, so we know that this can be multiplied. Diamonds can be multiplied. What about addition? 5 plus 6 is 11. Okay, and 4 plus 11 is 15. What's 4 plus 5? 9 plus 6, 15. So it's addition and multiplication. Okay? Still can't tell. This next one, same thing. We're not too sure. Zero is 0 plus 5. If this is plus, is 0 plus 5 0? No, this one has to be multiplied. Right? It has to be multiplied. 0 times 5 is 0. Okay, which means the circle has to be multiplied. Or no, sorry. The circle has to be addition. I'm sorry. Okay, so diamond is multiply, circle is addition. That's when we can finally get to our correct answer. So we can say that diamond equals multiply, and circle equals addition. Did you have to do all these steps up here to solve for that? No. You could have went right to these two and figured it out. And that's what the question asks. It just said, what do those symbols represent? And then justify your answer. It does say state each algebraic property being illustrated. I didn't do that. My apologies. Okay. And I'm not going to. I'm going to go down here. I'm actually going to go to number 4 here, because now we're actually using real numbers. 3 times x plus 1. So what are we going to do first if we solve for this? We distribute, right? So we'd have 3x plus 3 minus 1 equals negative 13. Property. Distributive property. Next, how do we solve this? We'd combine like terms, right? So we'd have 3x plus 2 equals negative 13. Combine like terms, CLT. Next, we're going to subtract 2 from both sides. We have 3x equals negative 15. What is that? That's a subtraction property of equality. You can say POE. That's okay with me. Lastly, how do we solve? We divide by 3. We can get x equals negative 5. You can also do this. Division, property of equality. Okay. We're done. Solve for x. Good. Down here, we're going to solve each equation and justify each step. I'm only going to go through, let's see here. I'll go through the last one. So I'm going to bring this up here just to get more room. We have negative 5 times 2u plus 10 equals 2 times u minus 7. Okay. That would be writing the equation if I had to justify that. I just moved it, so I'm not going to worry about it. First step, what do we do? How do we solve for u? We distribute, right? We'd get negative 10u plus negative 50 or minus 50 equals 2u minus 14. Okay, so this is distributive property. I know it's hard to see, kind of on the right side there. Next step, we can do multiple different steps. It doesn't really matter. I'm going to add 50 to both sides. Okay, but that's not saying you couldn't do something else. So I'm going to end up with negative 10u equals 2u, what is that, plus 36. And what do? I add it on both sides. So that's the addition property of equality. Next, I'm going to subtract 2u. So I'm going to get negative 12u equals 36. That is the subtraction property of equality. Lastly, I'm going to divide by negative 12. And I get u equals negative 3. And that's the division property of equality. Okay, so a lot of these just solving for the equation or the variable, and then writing down the property. This next one says solve the equation for the given variable and justify each step. So we want to solve for, right here, it says y. It gives you that equation and it gives you the variable. We're solving for y. Okay, so we have, just to make more room, we have 9x plus 2y equals 5, and we want to solve for y. To solve for y, we need to get y by itself on one side of the equation. Okay, so first step, I'm going to subtract 9x. We get 2y equals 5 minus 9x. What did I do? I subtracted on both sides. So subtraction property of equality. Is y by itself yet? No, it still has that 2, so we got to divide by 2. So we're going to get y is equal to 5 minus 9x divided by 2. That's the division property of equality. And I'm done. Yeah, I got y by itself. That's exactly what they asked us to do. I'm going to leave number 5 for you guys. Number 6, we have this big formula. Okay, where r is radius and s is the slant height. Solve the formula for s. Justify each step. Okay, I'm going to do that. I have s equals pi r squared plus pi rs. Solve for this little s over here. Sounds good? First, I'm going to subtract this pi r squared. Okay, because everything that's touching has to go over at one time. Those are all being multiplied together, so minus pi r squared. So I'm going to get s minus pi r squared equals pi rs. And I'm going to solve for that little s. So I'm going to divide by pi r, divide by pi r. It looks like pi's cancel and one r cancels. So this will just be, so we're going to get s minus r equals s. And what I do, sorry, I needed to, this step in red was subtraction, property of equality, and the step in blue was division, property of equality. And then it says, find the slant height, so that little s, of the cone when the surface area is 113 and the radius is 4. So all we really have to do is take 113, subtract 4 equals s. That's going to be 109. Okay, that is all.